Hi guys, it's Miss Fifield. I'm going to do your week 9, day 4 packet with you today. It's the last one I'll be doing with you. Tomorrow's your last day of school and your last video will be coming from Miss Cotter. So this is my last video with you for 3rd grade. If you hear dogs barking, I'm so sorry. I'm with 2 dogs right now and they like to bark a lot. So hopefully that's not too distracting for you because I can't make them stop. They just keep barking. Okay. Your packet, the first thing, the fluency, it should look like this. So this says draw 2 lines to divide the quadrilateral below into 4 equal triangles. I'm going to use this line tool here, and it's going to help me draw really straight lines. You can just use a pencil and make it as straight as you can if you have a ruler, or even like if you have like the edge of a book, you could set a book down and draw the line there. So draw a line to divide the quadrilateral into 4 equal triangles. I see triangles just by looking at this. I'm seeing like this. So I know if I draw a line from here to here, I have 2 triangles, but I need 4. Can I draw one more line? I would need to draw a horizontal line, right? So we can draw a line right through here. And now we have 1, 2, 3, 4 equal triangles. This next one says to draw 4 lines to divide the square into 8 equal triangles. I can see that if I go diagonal this way, I can make 2 triangles. So I think if I go this way, okay, now I have 4. I can only draw 2 more lines and I need to make 2 times as many triangles. So I can actually go a perfect vertical line. See, that made that bigger triangle up there into 2 smaller ones, and same here. And I can do a perfect horizontal, and same thing. I have 1, 2, 3, 4, 5, 6, 7, 8. Describe the steps you took to divide the square into 8 equal triangles. So you can say, I started by drawing what are they called? Diagonal. Drawing 2 diagonal. There we go. Can't spell today. Which made, we did that. Then we had 4 triangles. And then drew horizontal. It's this way. Vertical line. 8 smaller but equal sized triangles. Okay. Take a minute, look that over. All right. Use the pictures to model equivalent fractions. Fill in the blank and answer the questions. First of all, let's remember, what does equivalent mean? It means equal or the same. So when I notice this line and this line line up. I notice these lines line up. Notice those line up right away. I notice the tape diagrams themselves are the same size. I notice that there's an equal amount shaded, an equal amount not shaded. I can shade 6/8 and then I can shade 4ths until the same amount in each model is shaded. It takes 3/4 to equal 6/8. So these are done and then they fill in these after. 6/8 is equal to 3/4. It's written out in words and then it's also written here in fraction form. 6/8 is equal to 3/4. The whole stays the same. What happens to the size of the equal parts when there are fewer equal parts? When there are fewer equal parts, the size of each part gets bigger. 4ths are bigger than 8ths. So remember, 1/4 is this size, 2/8 the same size. Okay, let's try it. Use the pictures to model equivalent fractions. Fill in the blanks and answer the questions. 2/10 is equal to blank fifths. Okay, so the first thing we want to do is fill in 2/10. So I'm going to get a little marker tool. Let's do yellow. And I'm going to shade 2/10. So I want you to do the same on your packet. Whoopsie. So you're going to like shade 1, 2, like that. I'm gonna get an eraser and fix that because that was pretty messy. Okay. All right, 2/10 is equal to how many fifths? I see this line right here is perfectly lined up with that. So I'm gonna shade my my tenths until I have an equivalent size. So I'm gonna use the same color. I'm just gonna shade, and I can see I'm already there. I don't need to keep going on my fifths. So 2/10 is equivalent or equal to how many fifths? It's 1/5, and then 2/10 equal to 1/5 here. The whole stays the same. What happened to the size of the equal parts when there are fewer equal parts? When there are fewer equal parts, there was only one equal part here. It was a bigger piece than these two smaller pieces here. Let's do another one. I'm going to switch up my color here. 1/3 is equal to blank ninths. I'm going to start by shading my 1/3 here at the top. You do the same in your packet. Okay. All right. Now how many ninths? I'm going to start just shading one at a time. Is that the same size? Nope, I have to keep going. I'm 2/9 now. Is that the same size? Nope, keep going. What about now? Is that the same size? Yes, so 1/3 is equal to how many ninths? 1/9, 2/9, 3/9. We shade it here too. 1/3 is equal to 3/9. What happened to the size of the equal parts when there were more equal parts? So there's more equal parts down here than there. There's only one part here. There are 3 parts here. Those 3 pieces are each a lot smaller so that they can together equal the size of this up here, the 1/3. All right, number 2, 6 friends share 2 crackers that are both the same. The crackers are represented by the 2 rectangles below. The first cracker is cut into 3 equal parts and the second is cut into 6 equal parts. How can the 6 friends share the crackers equally without breaking any of the pieces? Okay. I can partition the first cracker, so this one up here, into thirds, and the second cracker into sixths. I can circle 6 equal amounts to show how much each friend gets. Okay, 3 friends each get 1/3 of the cracker, of the first cracker. The other 3 friends get 2/6 of the second cracker. They all get the same amount because 1/3 is equivalent to 2/6. So whether you get this piece or this piece, it's the same amount. This is just one bigger piece, and this has 2 smaller pieces. Okay. Let's try. Example 2. 8 students share 2 pizzas that are the same size, which are represented by the 2 circles below. One pizza, another pizza. They notice that the first pizza is cut into 4 equal slices, and the second is cut into 8 equal slices. How can the 8 students share the pizza without cutting any other pieces? Okay, so they need to share it equally, right? This first one's cut into 4 pieces. So we're gonna do, actually, you know what? I'm gonna get my line tool because it makes nice straight lines. I can't draw straight lines very well. All right. A horizontal and a vertical line is going to give us 4 equal pieces. Make sure it's as close as can be. Okay. And then this second piece is cut into 8 pieces. So I'm going to start by making it 4 pieces the same way I did that first one, like this. Okay. And then I need 2 times as many. So I'm going to actually cut each one in half by going diagonal. Okay, like this, through the middle as best I can, and making sure that these pieces look as fair as possible. Nobody wants to get the smaller piece, right? Okay, how can they share with 8 people? So what we could do is we could have one person would get this piece, one person would get that piece, 3, 4. Okay, so 4 people have gotten pizza, right, from this one. How can we make sure it's fair over here too? They need to get the same size piece. So how many slices from this smaller sliced pizza is each person gonna get? We need to get 2, right? Because these 2 smaller pieces are equal to 1 bigger piece. Because 1/4 is equal to how many eighths? 2/8. Okay. All right. Use the pictures to model equivalent fractions. Fill in the blank and answer the questions. 4/6 is equal to blank thirds. So we start by shading 4/6. I bet you guys don't even need my help on this. If you want to pause it and do the work by yourself and then hit play again and check your work, you can do that. I think most of you are probably good to go at this point. Okay, 4/6 shaded here is the same as how many thirds, so I should probably shade a little better. Okay, and then I start by shading 1/3. I see that that is not enough, that is not the same. So I go ahead and do a second third, 2/3. Now it looks the same. So 4/6 is equivalent to 2/3. 4/6 is equal to 2/3. The whole stays the same. What happened to the size of the equal parts when there were fewer equal parts? Here there are fewer, right? There are only 2 equal parts, where up here there are 4 equal parts. These 2 equal parts are bigger pieces than these smaller pieces. What happened to the number of equal parts when the equal parts become larger? The big pieces, there aren't as many. The smaller pieces, there are more, but they are the same size. All right, 1/2 is equal to blank eighths. Here's 1/2. And then I start shading my eighths until I have the same amount. 1/8, 2/8, 3/8. Still not there. 4/8. Okay, we have 4/8 is equal to 1/2. 1/2 is equal to 4/8. The whole stays the same. What happened to the size of the equal parts when there were more equal parts? So down here there are more equal parts. There are 4. They are much smaller. One little part down here is much smaller than this big part, but all together the 4 equal parts are the same size as the 1/2 above. Okay. 6 friends want to share 3 chocolate bars that are all the same size, which are represented by the rectangles below. But when the bars are unwrapped, the friends notice the first chocolate bar is cut into 2 equal parts. The second is cut into 4 equal parts, and the third is cut into 6 equal parts. How can 6 friends share the candy bars equally without breaking any of the pieces? Let's start by decomposing the way that it's described here. So friends notice that the first chocolate bar is cut into 2 equal parts. So I'm going to do that. That looks maybe fair, maybe a little bit. Okay, that's probably better. And the second one is cut into 4 equal parts. So I'm going to go, I know when it's fourths, I can do half, and then each half can be decomposed in half. And then the last one is cut into 6 equal parts. 6 is also even, so I start with this here, and then each half needs to go into thirds now because 3 is half of 6. So these 6 should be smaller than these fourths up here. Make sure. And you can pause the video and take your time and make sure everything is good to go if I'm moving too fast for you. Okay, so there are 6 friends. There are 3 of these. So I'm going to use a circle tool. Let's see, what if my first friend gets this piece? Okay, so the first friend gets this half. And then what if my second friend gets the other half of this first bar? 1/2, 1/2. That seems fair. Do you see a pattern somewhere where you could continue, where they could get the same piece? I'm going to use that same size circle. How many fourths would be equivalent to that 1/2? 2, right? They would need to get 2 pieces there and another 2 pieces there for it to be fair. 2 of these smaller pieces equal 1 of these bigger pieces. What about down at the bottom? We would need 3. Oh my goodness. We need 3 of these even smaller pieces to be equivalent to this 1 piece or these 2 pieces here. And same thing here. So everyone is getting the same amount, the same size, but these first friends up here, they would each get 1/2 of a candy bar, right? And then these friends down here are getting 2/4. And the friends at the bottom would be getting 3/6. But those are all the same. So what I'm going to do between each of these is I am going to put equal signs because 1/2 is equal to 2/4, which is equal to 3/6. All of these are equivalent. All right, that is all of your work for today. I know you guys are working so hard on your packets. Keep it up. Continue calling your teachers if you need help. We're still here for you. Let us know if we can help you in any way. And we will see you soon, guys. We're going to have a party on Teams today and another one tomorrow for your last day of school. So today, Thursday, the 28th, and then also tomorrow, Friday, the 29th. So we're going to have 2 parties on Teams, okay? So we will see you soon. Bye.